Hello, today I am going to be unboxing an Infranor PACHP AK23017 and FP23 slotless servo motor demonstration kit. On the left is the servo motor drive found in the kit, and on the right is the slotless motor. Additionally, we are going to cover what's inside of the kit and various configurations you can use the kit in. Here is what the kit looks like and what you will find inside. To start, you will find various supplier documentation such as motor pinouts, motor test results, drive information, a USB cord for connecting to the drive, a DB26 gender changer, and an Infranor I/O board. This is the default state you will find your kit in. Once the kit has been opened, it is safe to connect the feedback from the motor to the drive into this port. Next, we will connect the DB26 cable from the breakout board to the I/O slot on the drive. Now we can turn on the two breaker switches that supply power to the drive and the 24 volts DC source, which is used to supply power to the I/O and STO. While the breakout board is in use, we can wire analog inputs to open pins to act as external I/O. This is the state you should receive the kit in, where the 24 volts is directly wired to the breakout board. For pins 19 and 21 are supplied with 24 volts and pin 20 to ground. The kit is designed to be used with a standard 15 amp 120 volt outlet. This concludes the default setup. Now, we will cover how to set up the Infranor input-output board in its two configurations. The more common configuration is on the left, where the board is mounted to the I/O breakout board, and the less common configuration is on the right, where the I/O board is mounted directly to the drive. Let's go over the more common configuration first. To start, we are going to attach the gender changer to the end of the DB26 cable that is plugged into the breakout board, and then plug the cable into the front slot on the breakout board. Next, we are going to plug the I/O board into the rear slot of the breakout board. In this configuration, the STO switch acts as an on-off switch for the I/O. As power for the STO is supplied to pins 19 and 21 of the breakout board and pin 20 to ground. If these pins do not have power, then an STO fault will be triggered in the drive. Now let's go over the less common configuration. In this configuration, the I/O board is directly mounted to the drive, and the 24 volts DC is supplied directly to the I/O board. Additionally, the breakout board is not in use in this configuration. This configuration allows the user to directly trigger the safe torque-off function of their drive, and may be useful to test drives in the field. Now let's go into depth about the I/O board. This is the layout of the I/O board. It allows for 5 configurable input switches that can be used to start the drive, trigger sequences, or be assigned to functions in the drive. Next, we have 2 analog inputs that can be used for current limit, profile speed modulation, analog torque control, analog speed control, and analog read when connected to the breakout board. The analog 1 input allows for differential input, and this can be changed with the switch above it. Next, 3 outputs which can be used to send data to other I/O devices. Additionally, before closing the demonstration kit, make sure to disconnect all cables and the I/O board to avoid damaging them when the kit is closed. And place the foam insert back into the kit. Thanks for watching. You can find more information about our motors and drives on our website, infranorusa.com. Also, you can find additional tutorials and product information on our YouTube channel.